All right, let's get started. Welcome. So, I want to give you, we have this ECS day today, and my talk is going to be about giving you an overview of where we are and where we want to go. So, one thing that we have talked a lot about is, of course, performance by default, right? Like we want to make this engine be not only high performance, we want to reach the theoretical maximum of what you can do with a game engine. And so, what does that mean? So, first of all, we have our C# job system, and that is all about how do we make it so we can write multi-threaded code that goes wide on all the cores. And the hard problem there is, how do you make that safe? Because of course, multi-threaded code is really damn hard to write and it's super easy to make mistakes. So we have a safety system that makes it so that if you create any possible race conditions, it will tell you. And that makes it so that almost anyone who has the ambition to write high-performance code can get in there and learn the rules of how to write good multi-threaded code, and the system guides you along the way. Then we have the entity component system. And you can think of the entity component system as the evolution of game objects. You know, game objects are similar to entities in some ways, and components are components. But what's different is that this is very focused on creating really tightly packed, the perfect memory layout for the perfect performance at runtime. Right? We want to make sure that when we're processing these crazy amounts of entities, we want to make sure that we're just beautifully laying out all the data and we're processing it linearly so that there is not a single L1 cache miss, that everything is exactly like the hardware wants it. Right? And that's how we get a lot of the performance gains. And then we have the burst compiler. And the burst compiler is about when we have those two things already, right? We have our multi-threaded code. We already have to follow a lot of rules about how to write that multi-threaded C# code. Then how do we generate the most efficient machine code for that? How do we get great SIMD code out of it? How do we make sure that the compiler can do all kinds of optimizations that you don't see in a normal C# compiler, right? Really going to the edge of what you can do on a CPU. So, I'm sure all of you have seen what we showed in the keynote yesterday. So this is what we can do today. So we have 5,000 AI agents flying around. We have 4.5 million renderers in this scene doing culling. And all of this is written in C# on top of Burst with jobs. There's very little running on the main thread anymore. And I think that's quite awesome, right? That's what we wanted to do. That is what performance by default means. And like a point that I really want to drive home is like some people have been asking us about, but what does that mean for mobile? Like I'm just making a small 2D mobile game. Like why should I care about the entity component system? And the point is, if you like any type of game, you can reach more users if you have better performance, right? You're always you have a vision for the type of content you want to create, and by having better performance out of the box and better base technology and a better way of writing code that lets you get the best performance, you can just reach more hardware and you can get your game to run on significantly more hardware. Like maybe that 2D game that was running on a mid-range device, now it runs on the oldest of phones. And you can just reach those people and you're just not worried about performance so much a couple days before shipping, and you're doing like last-minute optimizations, getting a dude in there who just optimizes and hacks your code together because you built it from the start with performance in mind. And battery consumption is part of that same equation, right? A lot of mobile games these days have to be efficient in their battery consumption, right? Nobody wants to have a hot phone in their pocket. We want to make sure that, we just want to start a frame, do all of our computations. Maybe we run at 30 frames per second. Do all computations in 2 milliseconds, and then we're done. We're just gonna sit there and wait for 14 milliseconds, give the CPU some time to sleep, and that's how you reduce battery consumption. So that's basically why these things really are applicable to any kind of content. Another super important thing in my mind is streaming. So this is what we can do. What you see here is a building. Each building in the demo that we showed yesterday is 30 to 200,000 separate entities. There's audio sources in there. There is tiny little renderers, like this. That is the piece it's made out of, right? So that's why there are 200,000 of them. And they're all in one of these buildings. And we stream all of that in, and we're running at a solid 60 frames per second, right? So all of that data is getting loaded and decompressed on the background. And then in one step, a whole building just gets loaded in, and it's available to the world. And that is usually where you get spikes. That is the hard problem, right? If you look at existing Unity or any other engine, like there is no other engine that has solved this problem properly. When you look at that, it's always that time when, in Unity speak, it's the activation time, right? Awake from load, your scene is now ready, and boom, like virtual calls all over the place, and it's really hard to maintain a 60 frames per second frame rate like that. And what the entity component system does, it helps massively with that, because we can just prepare all of that data, and we can react to these things coming in a really, really efficient way. And we're proving that with this demo by having we just said, okay, what is the craziest thing we can do? Okay, let's throw 200,000 entities in there, activate in the same frame, and let's make that happen. And it happens even on a mobile phone. Then we have the rendering side. So we started working with the graphics team in Unity on figuring out how do we make a good renderer for the entity component system, right? How do we make a scalable renderer? 4.5 million renderers in the editor, smooth, all displaying. So we made a new culling system. The cool thing is it's all C# code now. So it's super flexible. You can plug in anything you like. You want to do a portal culling system, something specific to your game, that's super easy to integrate there now. And then just a lot of work on making sure that the rendering inner loops, they are insanely well optimized. There's some really great work that the graphics team in Unity did to make that happen. So that's the kind of things we can do, right? Like that's where you see like all of these details are because there's little models, and then it goes all the way to H-lots in the distance where there's just a building is represented as a single mesh in the distance. But like these pieces they're all there. We just don't render them necessarily when they're in the distance because we can combine them into a big piece. Okay. So then we also have put a lot of effort into networking. So so we have released the first person shooter sample game yesterday. And you have the full source code to it. You can see how do I make a 16-person, first-person shooter. It's all the netcode in there. It does lag compensation, it does client-side prediction, there's an authoritative server, there's tooling to launch these servers, all of these things that Peter has been showing. So that's what we have today. 16 players, network match, all the code available, easy to do. And that's built on top of what we call hybrid ECS, right? Using all of the existing features inside Unity, animator components and everything, but the game code is written in an ECS style, and the netcode is written in that ECS style as well. So that's what it looks like. Now, next up, we want to focus on determinism. So why do we care about determinism? We think that, similar to what we did with performance by default, right? Like really, let's start at the bottom of the stack and let's just nail performance. And then we can move up to a bigger scale, right? So in this case, determinism makes it significantly easier to write all kinds of multiplayer code. So if I can write deterministic code, so I can write floating point math code on a Linux server, and I can run the same code on a Mac laptop and the same code on an iPhone, then that opens up so many opportunities for how you can do networking, right? There's many different ways to do networking, from how you do a real-time strategy game to how you do a first-person shooter. But determinism underlies all of that. If we nail that, everything gets simpler on top of it. So we're going to do that. So in the burst compiler, we're now working on bringing determinism to that, so that it really truly, you can just say on a job, I want this code to run truly deterministic. And then we'll make sure floating point math code is totally deterministic across all the CPUs. And then all the different subsystems in Unity can follow that. So if you want to, maybe at some point we'll have a physics engine. If you want to have determinism in that physics engine, you can just turn it on in the compiler. And then we want to go after scale. So now we have 16 players and a good networking model for that is sort of like a really state-of-the-art, what you need in a competitive game. And now we want to go after scale. How do we put, like a lot of players, multiple hundreds of players on the same map, in the same server, running smoothly, beautifully on a server, using as little CPU as we can, right? So that's what the focus is on now. How do we actually do that? So there's a lot of stuff. But have we mission accomplished? I don't know. I think, I don't want to be the guy on the ship who says mission accomplished and then turns out it's not so. So let's not say that. I think where we are is we have a really solid foundation for performance now that we can build upon. And I think we've proven that as a team, we can do that. There's still a lot of work, there's a lot of features to build, and there's more performance to be gained for sure. Like we will always push on that. But I think we have, I think we can say we have earned the credit to say, like, we know how to do that. So in that sense, maybe it's time to talk a bit about something else, like take a bit of a hard right turn in this presentation and just say, that's cool, we know this stuff. There's a lot of presentations later today about exactly how we did the rendering and all these different things. So let's go in a different direction. So let's go there. Ease of use, right? I follow the forum a lot, and I can tell you for sure, there's a lot of people worried about ease of use. And so am I. I think, personally, I believe I have some credibility in what it means to build a simple game engine. So you can trust me, I hope. But what does it mean? So we've been thinking about this problem a little bit, and so far our focus has definitely been on performance, right? Because that's the thing we wanted to nail, right? Like, there's only so many hours in a day, and I very much believe in focus, so that's why we said, well, we kind of know how we want to do tooling, we kind of know what we want to end up with for simplicity. It should be simple, but we don't know yet how to do performance, so we focused on that. And we went at it, and we're in a reasonable place now. So let's talk about that. So what does it mean? There's the code, and there is the how do I author my content aspect to it. So the first one is Lambda functions. So this is my definition of what good looks like in terms of simplicity. And what you can see here is we're actually writing main thread code, right? This is not about writing the most performant code. We still want to make it super easy to write high performance code. We want to make it pretty much almost as simple as that. But there are some things, when you write multi-threaded code with perfect linear memory layout, they will always be a little bit harder. I mean, at some point, there is, like, you can't have the cake and eat it too. That's just, it doesn't exist. But that doesn't mean that it should be hard to do the simple thing, right? And that's what this is about. So a couple things we want to see here. So first of all, there's a lambda function, right? There's a for each. Everything is in context on a single line, and you just say, okay, I want to iterate over everything that has a spawner component and a position component. Cool. And in every frame, we're just going to instantiate a thing there. Great. Then we're going to instantiate that thing. So what that implies is we want the same workflow you used to for prefabs, right? It applies 100% the same thing. You just call instantiate. Done. I mean, that's how you do it. There's no reason to change it. It's beautiful. It works. So you get the instance back, and then you set the position component on it, right? Like, we want to place that thing at the position of the spawner. And then comes another thing that's actually, that's also relatively difficult, and that we still don't have in the code we ship today, but we want to do, is now you have this component at the top, right? The character definition. Let's say it has two properties, right? It has health and a name. And the health should get inherited from the prefab, right? We just instantiated it, and now we want to change just one value on it. So we should just be able to change the name on it in a single line of code, right? Today, in fact, we can't do that. And that's a problem. We need to fix that. So that is my definition of what good looks like. That's what we're going to be working towards to make that easy to achieve, right? This is the goal. And on the high performance side, we're going to aim to get as close to that as possible as well, right? Like that same pattern for each. You could imagine just changing it to for each jobified, and the code could actually be pretty much the same for multi-threaded code too. Right? It's not harder than that. Because we take care of all of the hard parts, right? The dependency management of all the data that you're accessing and so on. Like, that would totally fit into that system. So there's work on our side to make that happen, but we're going to do the work. All right, so then the next thing is classes. So right now, when you are using the entity component system, and actually, how many of you have looked at it and have used the entity component system? Okay, so a good half. So those of you know, currently we're doing everything with structs. And structs are super important because they give us the memory layout that we need in order to get that great performance, right? We don't want an L1 cache miss because every time we access a variable, we're jumping around in memory. right? The problem with classes in C# and in C++ as well and so on is you're just allocating that memory and you have no control over it. It just ends up somewhere random. And then you access a variable, health for name. It's in a random memory location. And then there's a third one, and that's also in a random memory location. And you have 3 cache misses to get to that value for health for name. So that is, in fact, not desirable for performance, right? You absolutely don't want that. And I'm making a lot of excuses for things we shouldn't be doing. But the reality is that sometimes this is simpler. So if you're making a big game that is focused on getting the best possible performance, don't do that. I mean, of course not. But the thing is, sometimes it's okay to do it simple. Maybe this thing exists only once in your world. And maybe you don't care about performance as much as that team that tries to really make that VR game run at 90 frames per second and just can't absolutely afford any GC allocations at all, right? Like maybe you just care about, you just want a good engine, but other than that, you just want to use it and have other people optimize code. I mean, that's not a wrong thing to say. I mean, of course, we want all of you to write performant code, but we don't want you to kill yourselves over it. So that's what that looks like. So let's make it so that we can have classes on these entities. You can add them, you can remove them. They're serializable, they show up in an inspector. Just like, nothing changes. It's not so different. So we have classes. And then the next question is, of course, what about editing tools? Today, if you dive into this brave new entity world, you are greeted with a desert of editing tools. And that's because we haven't built them yet. And there's this hybrid mode where you can edit some of these things, and in fact for the Megacity demo, that's what we did, right? We used prefabs and game objects, and we just had a thing that converted these things into the entity representation, right? So we just had some code that does the conversion, and that we're going to ship, and that way you can assemble your scene in the same ways. But that's not the end goal. The end goal is this. Right? What we want to do is change very little. We just want it to work with entities. So this is a new editing tool that is entity native. Right? So we have a hierarchy, we have a scene. Scenes are hierarchical. We have a hierarchy of entities, and you can select an entity. It has a name, and at least in the editor it has a name, because names actually cost memory, so why pay for it if you're not using it at runtime? But in the editor, it turns out they're useful. Yeah, right? So you have components, right? You have a transform component, you have a speed value. This is what you know. This is what you're already used to from game objects, and we literally don't want to change it. We want to make better tools in general, but the basic concept is the same. There's a hierarchy, there's a scene view, there's a game view, there's an inspector, there are assets. That's it. It's not, this part is not revolutionary. We just want awesome workflows. We're cool with the way we do workflows. We want to make sure that it also performs well. We want to make sure that the size that you can get out of this content, right? You can make a game like you're seeing there, you can ship that, and it's 100 kilobytes of executable size. That's what we want to do. But in terms of tooling, we just wanted to make you feel at home in a tool that you already know. And then, of course, there's features, right? So we're building this stuff alongside with you. That's literally what we're doing. So now if you're asking, where are all the features? Well, they haven't been built yet. Like, we have hybrid mode where you can interact with existing features, right? And that's quite useful because that way you can use it today and you can use mesh renderers, and if we don't have a physics system that is ECS native yet, then use the old one, and that's totally fine. Now, in this hybrid mode, there's no magic in terms of performance. It's still the old code running, so that doesn't get magically faster, and it doesn't magically get you multi-threaded code. But you can start carving out the parts of Unity where you can then start using them. Like now we have a new rendering system, and that scales. And we're gonna start building these features, right? So the focus on those, it's, as you would expect, it's the big 7 that you pretty much always need in a game engine, right? It's graphics, animation, audio, physics, AI, netcode, and input. That's the basics. Without that, you don't have a game engine. So we're doing that. And that's kind of the next step, like really, let's make a real full game and as much of it in this new, brave new entity world that we're building. Some of those we have, right? Graphics, we have a good amount, there's still a lot left. Netcode, we have a good amount, like a good starting point, but there's a lot more work. Audio, we showed you, that's actually really far along. The audio team has done some great work on bringing all of this stuff to C# into Burst and making something that really truly scales amazingly well. And the other parts, animation, physics, input, AI, those are all things that we're working on and that we're going to ship one by one, right? We have this in preview, and features are going to ship one by one as they get ready, so that you can get us feedback and you can work with us, right? Our intention with all of this is we're doing all of this in C#, right? We want to give you access to the source code for it under the it requires a Unity Pro license for the source code, for the C# code, and you have all the code available to you. You can make pull requests and everything. Right? That's what we want to do. So that's it. I intentionally kept this talk short. There's a lot of talks after this about a lot of the details where we're going to dive super deep into anything from the netcode to how we did the rendering, the audio, how we assembled the megacity scene, and so on. So now we have time for questions. So yeah, I think there will be mics. Yep.
Are those going to be supported?
I think the mic is on now.
Oh, okay, great. Question about lists and strings. Are those going to eventually be supported in the struct iComponent data, or do you have any recommendations for how to deal with those within the ECS system?
Right, exactly. So the question is, it's cool that you do this class thing, so I have a way out, but I want to write fast code. How do I do that? Because I need lists and I need strings. So lists we actually have, right? We have dynamic buffer, and that is in fact the solution we propose, and it is insanely efficient in the way that you don't have an L1 cache miss because the memory is laid out. You can have an automatic capacity for a small amount of elements, and then it flows over into a full allocation if it exceeds it. So that's what we think is a good way of dealing with lists on a component. So that's there. You can use it. That shipped months ago. Then there's the second question, which is strings. Strings we haven't solved yet. It's my friend there. Andreas, he loves solving this problem. Or someone else will solve it. But yes, we absolutely need to solve strings. So that's another one that's on the never-ending list of things. Well, it's not never-ending actually. We're in a good place, but we'll get to it for sure. That's important.
All right, thanks.
You're welcome.
It was great to see the list of things that you have upcoming that you want to apply, things like ECS to. Where would gravity fall in the priority of those?
Where would what fall?
Gravity.
What is
Or
gravity?
I'm sorry, not gravity, physics.
Well, physics is super important. I would love to say more, but right now I can't.
Okay, thanks.
You can take that for whatever you can try to read into that.
Hey there, thank you. This is very exciting. I want this, I guess we want this in commercial grade quality. I would like to challenge you to get completely out of your comfort zone, do something like what you did with FPS Sample, but this time for real. I want you to make Mega City Royale and release it on Steam, and the day you do it, you tweet mission accomplished. That way you tell us that you are there, and that would be awesome. Just saying.
I love it. That's a great plan. We should totally do that. Why don't we talk next year?
All right.
Yeah, I was wondering, is any of this switch over to ECS going to be automagical? Are you going to be rewriting any code for us, basically?
Sorry, say it again. I didn't get it 100% the question.
So I was just wondering how much of this is going to be automatic. So if we're using 2018.2, for example, right now, and we want to go ahead and start working with ECS, obviously we have to do a lot of rewriting of our code to make it work.
Right.
Is there any plans for making this automatic?
Right. So the answer to that is no. And it's not because we don't care.
You clearly do. It's okay.
Well, I'll tell a bit of history of how we ended up in this place. So, 4 years ago, I tried I was in Canada with a friend of mine, Robert, and we were rewriting the transform component to be data-oriented design, really fast, well optimized, and so on. And we built that on top of this object-oriented foundation. So we put a data-oriented design layer on top of object-oriented code. And we have that in a couple places. Our rendering code is largely written like that as well. So we did that, and then we tried to ship it, and it took a year and a half to get it to a place where it could ship, and it had a lot of regressions. And it improved performance, for sure. I mean, like 2-3x. But 2-3x improvements is not what we're after. We're after 100x improvements, right? I don't want to fuck around in my life trying to get these small multiple x improvements. We want to go to the boundary of performance. So the thing I realized after we did that for 1.5 years is if I keep going on this path, then I'm going to sit here in 20 years and it's still not going to work. So that's how we ended up in this place where we are basically saying, well, we're just going to build a parallel thing that you can mix with the existing code. But you have to transition your things over manually. Now that's for the code, right? If you want fast code, you have to write your code with principles that make it fast. There is no magic. Sorry. But content is a different story. For example, these scenes are just Unity scenes. They're prefabs, they're mesh renderers, they're LOD groups. They're the same thing. That's it. And there's a thing that converts it, and now it's fast. And that's when the backend code is there, and there's the conversion code, then you can move your data over. And we'll see exactly how much of this conversion code we do. Probably not 100% conversion, right? Because if we say 100% conversion, then what that means is we're also bringing the baggage, right? We're going to say, let's say 90% conversion, right? We're going to do a good attempt, but we're not going to do it at the expense of how good we can make the engine at the end.
Thank you.
You're welcome.
My question is in regards to the burst compiler. Will there be improvements to the profiler so that we can really learn how to use it to best practice and improve performance to the maximum with the new tool?
Yes. So, definitely. I mean, we have big plans on making burst and the burst inspector and building all kinds of performance tools. I think performance is about, first of all, developers understanding performance. And that's a hard problem that hasn't really been solved in all of programming, and we want to solve that. We want to actually make it easy to visualize what does your code actually do, and where's the delta from the code you have right now to what good looks like. And so that's super important. We absolutely believe in that, and we want to make the best tooling to iterate, especially on performance-sensitive code. Like we have some really good ideas and too little time, but we will get to it. It's just step by step.
Hello. Yesterday I was watching the visual effect graph, right? And it's pretty oriented at people not looking at the code to do amazing things with a lot of particles and game objects and etc. Seems to fit perfectly with bus compiler entity components. How integrated is it gonna be so the code guy doesn't have to punch the visual effects artist saying, dude, turn down the effects, man, like this is crazy.
Right. So right now actually the VFX graph is based on game objects and components, right? Like the VFX graph is basically there's a component on a game object that drives a system, right? One particle system, so to speak. I mean, in the VFX graph, it's different from Shuriken in that there are multiple systems on one component, so to speak. But let's say it's one system, and that's on a component. The integration that we would like to do sometime soon is bring it onto an iComponent data, so that you can just work with it natively as an entity. But that said, it's kind of a separate system. The VFX graph compared to entities itself. If that makes sense. Or like maybe that was not the question exactly, or did it answer it?
Yeah, I didn't think that's going to be integrated right now, but the plans for the future, like if it's going to be seamlessly, that's my question.
Yeah, I mean, the honest answer is I don't know, but I share the sentiment that these things being well integrated is a good thing, for sure.
Amazing work. I mean, really exciting.
Thank you.
Overall, right now it says not production ready. I'm going to ask the horrible question. When production ready?
When production ready? Right. Well, the way we're developing these things is really in terms of samples, right? Whenever we release a sample, what we're basically saying when we release that sample is that that specific type of thing is ready to be used. Okay. I mean, I believe the entity component system, like the foundation, like Burst, job system, I mean, job system shipped in 18.1, right? That's production ready. Burst compiler is still in preview. Mathematics library is still in preview. Entity component system is still in preview. I think that foundation itself, I would say Q1 2019 or something around that time. It seems like it's solidifying, and I think at that point we'll be at a place where we're sort of pretty certain that the APIs, they're solid. Our code in general is quite solid. I mean, we are very rigorous about unit testing. And on top of that, we're making these productions to, to weed out all the bugs. So code base is stable, but we're still changing APIs. And then in these productions that we're doing, you need certain features, right? And with every production, when we ship a sample game, and we're going to focus a lot more on these kind of sample games, then you will see this particular thing is now production ready. And it's production ready because we actually tried it. So that's more the concept, that's more the direction we're going. It's in fact quite different from how we've done things in the past.
So the generalized patterns are not going to shift much from where they are today, just looking at, basically learning the ECS, and there's a variety of different patterns you guys are using. Not going to shift that much, or do you expect more change?
Well, I would say at the end of the year, that's probably true. Okay. There's still a lot of, now when you look at the anti-component system API, there's 6 different ways of doing it, and we're going to cut 4 of them. But archetype chunk, iJob, process component data, those are the ones that you should be using, and they are here to stay for sure.
Thank you very much.
Hi.
Hi.
It's really cool to see what ECS will be, and I was at the TikTok Games talk yesterday, I was at the Intro to ECS talk yesterday. What problems do you think ECS is best at solving today? If somebody wanted to start using ECS and try solving problems with their game, what problems is it good at solving right now?
Well, right now the main problem it solves is anything performance related. If you want better performance, use ECS. That's a very simple way to do it. The second problem it solves is networking. The story there is not, it's halfway complete, I would say. But in a lot of ways, the FPS sample game uses hybrid ECS, for example. So that's also an example of where an ECS-style approach actually simplifies netcode quite significantly. So I think those 2 things, if you care about one of those 2 things, that's a good reason right now to get into ECS.
Okay, thank you.
You're welcome.
Hello, I've been very excited to see, not just at this Unite, but previous Unites, you've been talking about determinism a lot.
Yeah.
And this kind of being a favorite subject of mine. And I'm curious, it seems like you're mainly going to be focusing on adding determinism to the burst compiler. But is there any thought given to how it might be brought further than that? Because it seems like just one float, non-deterministic float operation outside of the burst compiler, or in the rest of the system, a global variable, anything like that, could poison the entire deterministic stack from there on.
Yes.
So is there any thought given to how we can, or how that can be expanded so that there's, obviously you can't rewrite, certain parts, but is there any thought given to that?
Right. I think what it's really about is really providing great tools for debugging that. One of the things that the anti-component system is great at is helping you understand your data. And you can see some of this in the entity in the system debugger, but we really want to dial that up to 11, right? Imagine you could drag a slider of your game and move it into the past. Those kind of things. And then maybe you could also see from one system to another, what exactly did it change? And then if you have determinism, you could have 2 computers run it, and then if they disagree on something, you could see a diff of exactly which system did it, because you can do that rollback. There's a crazy amount of tools we could be writing, and there's plenty of ideas. So I think, the short answer is just invest heavily in tooling to solve that. And you can't write floating point math code on the main thread. It's like that. you're not going to be able to do that if you want deterministic code. That's basically what we're saying. Has to be in C# burst. We have to cut one more question.
Yeah. So you mentioned unit testing earlier, and you know, my life with unit testing in Unity has been really difficult, and so I was wondering, you know, in the FPS example, I haven't looked at it yet, but do you have any? Are you releasing any examples of your unit tests so that we know
Yes.
how to test our code?
Yeah. So if you look in the packages folder, that is in like into the package folder for the entity component system, it has all the tests, and you can also enable them by, I mean, in the manifest file you can set like there's an attribute to set like a testable package, and then all of these tests that we're using, all 700 of them, you can run them in the Unity test runner, and you can see exactly how we wrote them.
So on the mono behavior tests, so I saw some blogs earlier on dependency inversion and things along those lines, but yeah, does it look like, you know, will the samples include from now on kind of include that sort of stuff? Is that
Dependency inversion?
to test a mono behavior currently right now? It's a lot of work.
Yes,
and,
it is.
And ECS solves that, right?
Yes.
And so I'm just curious, in the ECS examples, will we be seeing more unit test examples, just so we can see how are you guys doing
Yes.
it, so that we can.
That's what I said. It's in the package. The test code is right there. You can look at it. Awesome. Thank you. So we'll be back there if you have any more questions. Thank you.